So welcome, this video is about hypothesis testing. So we will start with the t-test that we apply when we compare averages of two variables with each other. So in our case, let's assume that our hypothesis is that Dunning-Kruger cases are happier in life than people who are not Dunning-Kruger cases. So we take the variable overall life satisfaction and the variable Dunning-Kruger factor 2 for that. So the first step would be that to get an overview over the data, that we create a frequency table for both of these variables. So we click on Insert Pivot Table, create a new worksheet. Now we take our variable overall life satisfaction into the rows and also into the values. Now we need to change from sum to count. Okay, and what we can see here, we have missing values, -9. So we first need to replace the -9 with NA for not available. Then we have a scale between 0 and 10. 0 are those who are very unsatisfied with their life, and 10 are those who are very satisfied with their life. So let's first replace the -9 with NA. So we click back into our table, click anywhere in our table, then Start, and here we have Search and Replace, and we take -9 and we want to replace -9 with NA for not available. Okay, we have 628 places where we have changed that. Now we can close again, and now we can compare the averages of overall life satisfaction for the Dunning-Krugers and the not Dunning-Krugers. So we click again on Insert Pivot Table. We take the already existing worksheet here. I click into the worksheet and OK. And now I take my variable Dunning-Kruger factor 2 into the rows and my variable overall life satisfaction into the values. And here I have to click in value field settings on average because I wanted to compare the averages. And what you can see here, basically there's not a big difference, very small difference, but still this is a big data set. So in big data sets, even small differences can be significant. So we need to test the small difference, if this difference is significant or if this difference is just a coincidence. So therefore we click into our data set again, and the easiest thing to do that, to do the test, from my perspective, would be that we take our two variables and copy them. So here we have the overall life satisfaction. So I click in the column at the top so that the whole column is marked. Control C for copy, and then I enter the first variable here, Control V. Now I go back into my dataset and also copy my Dunning-Kruger factor 2, Control C, and then go back and enter it here, Control V. Okay, what I want to apply now is the t-test. Let's have a brief look at the t-test. So the formula for t-test is t-test. You have to start with equal t. If you use a Russian or Spanish notebook, you need to look what the formula for t-test in your language is. But English is also t-test. Now here we have the syntax, and that syntax is also different. Here I have the German syntax, so in the English syntax I think instead of a semicolon you need to take a comma. But what he basically wants to have, he wants to have two arrays with numbers, matrix 1 and matrix 2. Matrix 1 would be all the values for the first group. That would in our case be the non-Dunning-Krugers, and the second group would be all the numbers for the Dunning-Krugers. Okay, so before we can do that, so I delete this again. Before we can do that, we need to sort our Dunning-Kruger factors so that the values that we need to have are all sorted. So I make a right click, click on sort the data smallest in the beginning. So here all the zeros are not Dunning-Krugers I have now in the beginning. Now again I apply my ttest. So equals ttest, double click, and now I mark the values for overall life satisfaction for all the people who are not Dunning-Krugers. So that is a little bit tricky because we have 3,000 data, 3,000 cases here in our data set, 3,000 participants. So maybe that needs some time. Here we are already at the Dunning-Kruger, so I have to go back. Okay, oops. It's always here we have the end. So now in English version, as I said, a comma. I need to take a semicolon, enter a semicolon, and then I mark the second matrix, the values for the Dunning-Kruger cases. So, and again, English version, a comma, German version, a semicolon. Now we want to have two numbers. First, if it's a one-sided distribution. So in our case, we just said that our hypothesis was that there is a difference between Dunning-Krugers and not Dunning-Krugers. So that would be our alternative hypothesis. Our null hypothesis would be there is no difference. So this is a two-sided distribution, and therefore we have to enter a 2. Then again, comma or semicolon. And now we have different sorts of t-tests. In our case, we have basically two samples. So we have splitted our sample into two samples, the sample of the Dunning-Krugers and the sample of the not Dunning-Krugers, which we compare. And we have not measured the variance of these two groups. So we cannot assume that we have the same variance. So therefore we assume that we have a different variance and enter just the 3 here. Then we can close the bracket and enter. And here we have a value for the t-value. And obviously what we can see that is bigger than 0.05. So therefore we cannot refute the null hypothesis. So we have not enough evidence to prove that this very little difference is really significant. So obviously my hypothesis is that Dunning-Kruger cases are a little bit happier than not Dunning-Kruger cases is not true. So this is basically the t-test. Now let's also apply the chi-square test. The chi-square test we use for cross tables. So let's have a look into our data set again. So let's say we have a higher percentage of female Dunning-Kruger cases than male Dunning-Kruger cases. Yeah, and just to remind you, the results of this data set, this is a representative data set. So if we find a difference between men and women here, then you can assume that you will find this difference also in the whole population. So we start with, again, creating a new pivot table. And now we have 2 times nominal scaled variables, so gender and also Dunning-Kruger case, yes or no. So therefore, we need to create a cross table. We put sex into the rows, and then we put the Dunning-Kruger factor 2 into the columns and also into the values. And here you see, here we have a cross table now, but you see the default position here is the sum, and the sum of no matter how many zeros will always be 0. So we need to change this. We want to have the count here again. So value field settings, count. Okay. So now you see we have 1773 male Dunning-Kruger cases, because I think one is are the males, and 1704 female Dunning-Kruger cases, but we also have a lower number of females in our data set. So now it's difficult to say if this difference is significant or not. So again, therefore, we seems to have, or the first thing would be that we create a new cross table where we have the percentage. So let's go again into our data set and insert a new pivot table. We take the same worksheet now. Here I want to have my new cross table, and here I also want to have gender and Dunning-Kruger factor 2, so gender into the rows, Dunning-Kruger factor 2 into the columns, and also into the values. And here I also need to go on value field settings and go on count. Okay. But now I want to, and now I want to have the percentages. So first I have to go and count, but now I also want to have the percentages. I want to know how many percent of the men or women are Dunning-Kruger cases. So I have to go on value field settings, and here I can calculate the percentage. And in this case, it should be the percentages in the row, because all men should be 100% and all women should be 100%. Yeah. Okay, so here you see now we have it, and now you see we have 16% of female Dunning-Kruger cases and 12% of male Dunning-Kruger cases. So again, the question is this difference significant, or is it just a coincidence? So we must test this. And therefore we would apply the chi-square test. And what is a little bit different in the chi-square test, it's a little bit more complicated, because I also must create a table with the expected values. So let's create the new table. So here we have the males, and here we have the females, and here we have the N for not Dunning-Kruger and DK for Dunning-Kruger cases. Same thing as here, 0 for not Dunning-Kruger or 1 for Dunning-Kruger cases. Now I need to calculate here the number, how many not Dunning-Kruger cases, male not Dunning-Kruger cases, would we expect if we have the same percentage of male and female Dunning-Kruger cases in our sample. Yeah, so which number would we expect? And then we can compare our observed values with the expected values. That is what the chi-square test does. And then we can conduct the chi-square test. So the expected number means that overall we have 85.85% of not Dunning-Kruger cases in our data set. So if the null hypothesis is true and we have the same number of not Dunning-Kruger cases among women and men, then we would expect to have exactly this percentage of male and female Dunning-Kruger cases. So to calculate that, we can enter 85. No, it's not working, I think. So we enter equals. So we have to type it in, 85.85%, and we need to multiply that with the number of men. So we have 1,773 men in our data set. Yeah? So we calculate what would be 85.85% of 1773. So this is a number that we would expect if we would have exactly the same number of male and female not Dunning-Kruger cases. So we can take this formula down so that I have not to type everything again. Then I just need to change the number here, because here I want to have the number of women, which is 1704. So 1704. So if we had exactly the same number, if we had 85.85% of women not Dunning-Kruger cases, then it would be 1462.884. Now we need to do the same thing, calculate the same thing for the Dunning-Kruger cases. So we have 14.15% of Dunning-Kruger cases in our data set. I should make the numbers a little bit bigger. So here we have the percentage of Dunning-Kruger cases. So if we had the equal number of male and female Dunning-Kruger cases, then we would expect to have 14.15% of all men. So 1773. I need the percentage here. That would be 250.88. And I also would expect to have here 14.15% of all women. The number of women was 1704, so I just need to change the number a little bit. Okay, so these would be the expected values now that which we would expect if the null hypothesis is true and we have no difference between male and female Dunning-Krugers, between the percentage of male and female Dunning-Krugers. Now you see, when we apply the chi-square test, we again start with entering equals, then it should be chi-test, Chitest. So here's the chi-square test, double click. And now he wants to have the observed values and the expected values. Yeah, so the observed values are the values that we have observed in our data sets for men and women. So we just mark the observed values, the number of Dunning-Krugers and not Dunning-Krugers for men and women. Then we need to enter semicolon or comma. In an English version, it's a comma. You can always see it here in the syntax. And you need to mark the expected values, which are the values which you would expect if the null hypothesis is true, that there are no differences between men and women. So I close the brackets. And again, here I have a value which is much smaller than 0.05. So that would again mean that the probability that the null hypothesis is true is much smaller than 5%. It's 0.047%. So we have enough evidence to refute the null hypothesis that there is no difference between men and women, and to assume that the difference that we can observe here is indeed a significant difference. Okay, so far with the Dunning-Kruger and with the chi-square and the Chitest, I propose that you test this now with another hypothesis. For example, you can use the hypothesis there is no the alternative hypothesis, there is a difference, the percentage of Dunning-Kruger according to different levels of education. Yeah, here the ISCET 2011. You can Google it or type it in Wikipedia. There you will see exactly what these numbers mean. So this is ordinal scale data, so that would also be a cross table and a chi-square test. The hypothesis, there is a difference in the percentage of Dunning-Kruger cases according to the educational level. And for the t-test, for example, you can use the hypothesis that there is a difference in the left-right spectrum between Dunning-Kruger cases and not Dunning-Kruger cases. Then you just compare the averages of the left-right spectrum. But as I said, you should start with first creating some frequency tables to see if you have missing values, and then you need to replace the missing values by NA. Okay, I hope this video was understandable. So try the hypothesis, and if you have any questions, ask me in the seminar.